Hello, and welcome to another episode of the Plutonium Bunny. Today I'll be showing you how to extract manganese metal from just batteries. Once you've taken the paste out of the batteries, I find it helpful to dry it in the oven and then ball mill it into a fine powder. A hammer or a mortar and pestle would also work for crushing it into a fine powder. I'll weigh out 100 grams of the battery paste and see how much manganese we get from that. Now I'm going to put the 100 grams into a larger container, and for the first step in purifying it, I'm just going to use some water to wash away all the soluble impurities. So I'll just stir that around and then let it settle and decant off the water. Now it's time for some kitchen chemistry. I've siphoned off most of the water, so now there's just a little bit remaining. And now it's time to put in some vinegar. This will dissolve any oxides present of zinc and things like that. It should start fizzing. As you can see, there is some fizz. The solution is now filtering. I let the vinegar sit with the mixture for about 10 to 15 minutes. Now it's just filtering through a rag. And I'll probably let that go until it kind of thickens up and then wash it with some water. And the last step will be to dry it out. Now that the manganese dioxide paste has finished filtering from the vinegar, it's time to put it on the hot plate and bake it till dryness. The powder finished drying, and in the end I was left with 85 grams of fine black powder. So this means that there were 15 grams of soluble impurities and impurities soluble in vinegar in the original starting battery paste. Now I'm outside because the next step is by far the most hazardous. It's time to add the hydrochloric acid to the manganese dioxide, which will dissolve it while leaving the carbon behind. And that should be good enough to get us started. The hydrochloric acid will not attack the manganese dioxide very quickly in the cold, so I'm going to need to get a hot water bath to really get things started. I've got the hot water bath and my green chlorine gas balloon set up now. I guess it goes without saying this is making chlorine gas from decomposing the hydrochloric acid, so just be careful. I tied a little rubber band around the base of the balloon to keep it sealed tightly. But pretty much now we just wait until it stops making gas and then just make sure that it's really done by adding a little bit more acid and keeping it warm. So I took the balloon off and noticed something weird. It's really heavy. A normal balloon, if you toss it up, it'll stay up for quite a while. But this balloon, if you toss it, it immediately comes back down. And you can feel how heavy it is. Whoops! If you drop it, unlike a normal balloon that kind of floats gently to the ground, that drops and kind of makes a dull thud. So that's because chlorine is 2.5 times as dense as air, which makes for a really fun experiment. The sludge has now stopped producing gas, so it's time to filter off that nasty carbon and just get the manganese salts with a bit of extra hydrochloric acid. I'm just filtering it through an old rag again because really it doesn't have to be a perfect filtration, just good enough to get the job done, and I want to go fast. Kind of greenish yellow in there, which means there's still some good chlorine, so definitely be careful. Do this outside and definitely wear safety glasses. The solution finished filtering, and as you can see it is a kind of brownish red yellow color, and there's definitely a lot of yellow visible where it splashes up onto the walls. Now manganese chloride should be a nice light pink color, so obviously this is not pure. To purify it, I'll be using the Nerd Rage Selective Precipitation procedure. And so here I have 10 grams of sodium hydroxide dissolved in some water, and I'll add that. Now it has made a kind of gross puke looking solution. These are the precipitated iron and manganese hydroxides, but it looks like I will need a little bit more, so I'll add that. And then after I finish the hydroxide addition, I will be filtering the hydroxides and then adding them back to this container where I have 2/3 of my solution saved. I've finished filtering the manganese and iron hydroxides now, and then I washed them with water to remove all traces of sodium. Now I've added those back into the main stock, and as you can see, there are excess hydroxides, so the solution is completely cloudy and turbid. It kind of looks like mud. So now I'll let this sit overnight, and what will happen is the atmospheric oxygen will oxidize the stuff in there. All the manganese hydroxide will get converted back into the chloride, and all the iron chloride will get converted into the insoluble iron hydroxide. I'll then filter that off and show you the end solution. It is the next day, and I've just finished filtering this for the second time. As you can see, the hydroxides got caught in the filter, and the solution is now pink. Marvelous! For the next step, I will be dividing this into the portion that I'm keeping for soluble manganese and the portion that I will be using for thermite to isolate manganese metal. I just thought I would show off this 35 grams of relatively pure manganese chloride. You can really see the pink color now. I will be putting this into solution and then neutralizing it with sodium hydroxide and washing the precipitate for the next step. Now as that's filtering, I'll explain how the rest of this is going to go down. So we have manganese hydroxide right now, but we need a manganese oxide for thermite. We can't use just any manganese oxide though. We need either manganese 3 oxide or manganese 4 oxide. Manganese 4 oxide is what we started with, the manganese dioxide from batteries. I couldn't find any good ways of making that from soluble manganese compounds, so we're going with manganese 3 oxide, or Mn2O3. How we get there is we bake this hydroxide in the oven after it's been filtered and washed, which oxidizes it to the manganese 3 oxide. That can then be used in thermite. As you can see here, it has darkened from the cream color into a kind of brownish color, so the air is already oxidizing it. The manganese hydroxide finished filtering, and then I washed it twice with water to remove all the sodium chloride. So now it is time to place it in the oven to drive off the water and then oxidize it to manganese oxide. And so I'll just be leaving it in the oven for about half an hour at 400 degrees Fahrenheit. Here is the final product, 16.3 grams of dark chocolatey brown manganese 3 oxide. To make the thermite, I will mix it with 5.56 grams of aluminum powder. The slag has cooled, so breaking it open should reveal the manganese metal inside. Here is the recovered manganese metal. I was able to remove it from the pulverized slag because it is shiny where it's broken, and the non-broken pieces are kind of round and melted as compared to the sharp alumina slag. This is 2.61 grams, so a 23% yield, which isn't too bad. And it is very shiny. I also did a larger thermite, a 60 gram batch. And as you can see here, it made larger pieces, which seems reasonable. And they are very shiny and beautiful on the inside where they've been cracked.